Okay, so we are now at question number 6. Let me write the question. The diagram below shows a hemispherical bowl and a cylindrical tin. The diameter of the cylindrical tin is 12 cm, the height is 17 cm, and the radius of the bowl is equal to r. Now they are asking us to show that the volume of the cylinder, or I would say the cylindrical tin, is 1923 cm cube. Correct to 4 significant figures. Okay, so this is the question. Now foremost, what we have to do is we have to actually find out the volume of the cylindrical tin. So let me actually draw the tin. So this is the tin, and we have the diameter. This entire diameter is 12 cm, the height is 17 cm, so this is the radius. So radius is equal to diameter over 2. So 12 cm is the radii, divided by 2 you get 6 cm, or I would say the diameter is 12 cm and you divide the diameter by 2, you get 6 cm. So the radius is 6 cm. So we have got the radii. Now the volume of the cylinder, what is the formula for that? The volume of the cylindrical tin, that is nothing but pi r squared h. Okay, so substituting the values, we have the following: pi times the radius is found to be 6 and the height is 17 cm. So value of pi is 22 over 7 multiplied 6 squared is 36 multiplied with 17. Now we will have to evaluate all of these. So what we can do is we can use the calculator to find out the values. Okay, so we're going to multiply 22 with 36 multiplied with 17, that is giving us a value of 13464 divided by 7, and that is equal to 1923.428. and the question is actually asking us to correct 4 significant figures. So that means the volume is equal to 1923 cm cubed. You have 4 digits here, so that is sufficient, and that is exactly what the question requires. Now we have to go to the next part of the problem. So I hope you are following this question. So let me write down the next part of this question. So we have the bowl that is coming into the picture. The bowl is completely filled with soup. Okay, when all of the soup is poured into the tin, only 90% of the tin is filled. Calculate the radius of the bowl. So this is the bowl, okay, and we are expected to find the radius r. Now this is the hemispherical bowl. Now already we have dealt with the tin. Now this has got soup, okay, and this is transferred to the cylindrical tin. Apparently just 90% of the tin is filled. Now they are asking us, with this data, they are asking us to get the radius of the bowl. Okay, so the first system that we can write here is volume of the bowl is equal to 90% of the volume of the tin. I'm going to just mention it as tin. It is understood that the tin is cylindrical in shape. So having mentioned that information, let me move on. So this is going to be rewritten as 90 over 100. The volume we got here was 1923. Okay, so let me substitute that 1923. Okay, now clearly zeros gets cancelled. Now I'm going to multiply 1923 with 9, and I get 17307 divided by 10, which is 1730.7 cm cubed. So what is this? This is the volume of the bowl. Volume of the bowl. Now what we have to do now is to use the shape of the bowl. The bowl is hemispherical in nature. So with this information, this means the volume of the bowl will be half times the volume of the sphere. Now volume of the sphere is 4 over 3 pi r cubed. The volume of the bowl we have found it as 1730.7. So rewriting this, we get 4 pi r cubed divided by 3 times 2 is 6, and you have 17307. Okay, it's 30.7. So you cross multiply. If you cross multiply, you get 4 pi r cubed is equal to 1730.7 multiplied with 6. This is pi r cubed is equal to 1730.7 times 6 divided by 4. Now you bring the pi down. So let me write that down here. So we have pi r cubed is equal to 1730.7 multiplied with 6 divided by 4, which can be rewritten as 1730.7 multiplied with 6 divided by 4. Pi is brought down. Now pi is 22 over 7. Okay, so I hope you're following. So r cubed is equal to 1730.7 multiplied with 6 divided by 4 times 22 over 7. I can rewrite the 7 in the numerator. So you have 1730.7 multiplied with 6 multiplied with 7 divided by 4 times 22 is 88. So you have to use the calculator here. So 1730.7 multiplied with 6 times 7 is 42. Okay, so this is giving me value of 72689.4 divided by 88. Now let me divide this number by 88. So that is giving me a value of 826.01. I'm going to take it as 6. What is this? This is r cubed, but we need r. R is equal to, you take 1 over 3 both sides. So that is going to give me r is equal to third root of 826.016. Now we can actually get the third root here. Okay, there is a function here. So I'm going to use shift and I'm going to key in the number 826.016. That is giving me a value of 9.38, and I'm going to give it as 3 significant figures. Okay, so this is the radius of the board. Probably you can write this down. So therefore the radius of the board is 9.38 cm. Okay, that is the conclusion for this question. Now this is the next part. So the following is given. So let me write this down in the diagram below. Points LMN are on the circumference of a semicircle with center O. Now the radius is 18 cm. Now what they are asking us is to find the area of the shaded region. So let me just draw the semicircle. So for the time being I'm using the protractor. Okay. So this is the center. Center is here. From the center there is a hit on the circumference, and then there is another hit here and another hit over here. So L, M and N, and this is O. Now the radius is given as 18 cm, so this point is 18 cm. Now we are asked to get the shaded region. Now this is a semicircle. Okay, I hope you are able to see the question and the figure. Okay, now let me get the area, or I would say let me write the required area formula. Required area is nothing but from the area of the semicircle we take away the area of triangle. Okay, so that's going to be the formula. From the area of the semicircle we take away area of the triangle. So first let me find out the area of the semicircle. That is nothing but half times area of the circle. Okay, so what is the area of the circle? It's nothing but pi r squared. So it's nothing but half times pi times radius is 18 squared. So 18 into 18. 2 divides here 9 times. So 9 into 18 times pi. 9 8s are 72, carries 7, 9 1s are 9. So 162 pi. Okay, square units. This is the area of the semicircle. So let me move on to the next page. Write it down. Area of semicircle is 162 pi, which can be rewritten as 162 times 22 over 7. Okay, now I can multiply 162 by 22. I get 3564. I'm not going to divide it by 7 now, so this is square units. Next, let me find out the area of the triangle. That is nothing but half times base times height. So what's the triangle? What is the base? Base is 18 plus 18, right? And what is the height? Radius is already given as 18. So base is going to be 18 plus 18. Height is going to be another 18. So 2 divides here 9 times. 18 plus 18 is 36. Multiplied with 9. 6 are 54. 5, 9, 3 are 27. 27 and 5 is 32 square units. So what is this? This is nothing but area of triangle. So what is the required area? Required area is area of semicircle minus area of triangle. So area of semicircle is 3564 divided by 7. Area of triangle is 324. So taking 7 as the LCM, this is 3564. 7 4s are 28, 2, 7 2s are 14, 15, 16, 1, 7 3s are 21. So when you make the subtraction, 3564 and then 2268, this is going to give you 6 and 9. From 4 you take away 2, you get 2, and from 3 you take away 2, you get 1. So this has to be divided by 7. So you can divide that. Let's see what we get. 1296 divided by 7. 7 1s are 7, you get a 5. 7 8s are 56 and 3 and 6. 7 5s are 35, you get a 1. Place the decimal, add 0, and then again you get a 1, and then you have a 3 there, and you add a 0, you get 28. So approximate value is 185.14 cm squared. So this is the area of the shaded region.